In this presentation, we are going to demonstrate how to solve a linear equation and a linear inequation. This is an inequality sign. It is always pointing to the smaller value. The point is called less than, the opening is called greater than. But the sign itself is an inequality sign, and this is an equal sign. So this is an equation, and this is an inequation. So we start with the equation. Now, what we need to do is to cancel out all the numbers that are associated with the letter x, that's the variable, so that it will be by itself on any side of the equation. Currently, it's on the left side of the equation, and it's positive, so it can stay there. So therefore, we have to cancel out the -6 and the 3. The -6 first, because it is being subtracted, and you can see it's like further away from the x, so it's easier to cancel it out first. And canceling out is the opposite of BEMDAS. BEMDAS, as you know, is the order of mathematical operations. It is the acronym for the order of operations used to evaluate an expression. It stands for brackets, exponents, multiplication, division, addition, and subtraction. So you have to do these operations in that sequence. And if you are canceling out, then you'll go basically in the opposite direction. So therefore now we need to do the subtraction first. And to cancel out subtraction, we have to add. To cancel out addition, you subtract. To cancel out division, you multiply. To cancel out multiply, you divide. So to cancel out -6, we have to add 6 on both sides of the equation. We also call this the golden rule of algebra, whereby whatever you do on one side, if you add 6 on the left side to maintain the balance of the equation so that the equal sign, remains valid, you have to repeat the same operation on the right side or on the other side, whatever side that you start. So therefore now, -6 has been cancelled out from the left side. And on the right side now, you've got a new number, which is 36. Because 30 plus 6 is 36. Now we have to cancel out 3 by dividing by 3 on both sides of the equation. The reason why we are dividing, because 3 now is multiplying to x. 3 is a coefficient. And to divide, to cancel out a coefficient, to cancel out a multiply, you have to divide. Now, if we divide on the left, we've got to divide on the right. So we divide by 3 on the right also. And what we are left with now, x now, is equal to, okay, because that's what we want to achieve, x alone on one side of the equation, x is equal to 12. So now we proceed with part B. Here we are going to solve this inequality. But if you look at the left side, that's where the x's are. You can see that there are different x's. So what we need to do is to bring like terms together. We have 7x here. So this plus x can come to make this plus 7x, and that -10, or subtract 10. Because we're promoting anytime you see you have that sign within an expression, always try to call it subtract or minus or take out instead of just saying negative. Preferably if it's hanging on the outside there, then you can say negative. Okay, or feel comfortable saying negative, but once inside you say subtract, for example. So therefore now we are subtracting 10 from 2. Okay, so I would say -10 plus 2. -10 plus 2, it doesn't really tell you what to do. So subtract 10 from 2. Okay, add 7 to x. All right, so therefore now we're going to simplify this left side. We're going to add 7 to 1. Not to 1. 7 plus 1 will give us 8. So we have 8x. And when we take out 10 from 2, minus 10 from 2, we have negative 8. We still have 8 to continue taking out, to continue subtracting. Okay, so say negative 8. After we take out 10 from 2, we still have 8 more to take out, if you want to put it that way. So now we have to cancel out the 8 now, the subtracting 8, the negative 8 if you want to will. So we have to do the opposite of subtract, which is addition. So we have to add 8 on both sides of the equation, inequation, to be precise. So if we add 8 on the left, we have to add 8 on the right. So just feel comfortable treating the inequation like an equal sign, okay? And basically, that subtract 8 has been cancelled out from the left side. And then we have a new number from on the right side, which is 24. Try to align the inequality sign so that you can see the process happening of cancelling out. So now we have to divide. You can demonstrate the division by using a fraction, numerator and denominator, or you can just use the division sign. Okay? And we are dividing because that 8 is a coefficient, it's multiplying to x. So we divide it on the left, and if we divide it on the left, we have to divide it on the right. So you can write your division like this. You don't have to write it like a fraction. And basically what you are left with is x has to be greater than 3. Now this can be represented on a number line. Okay, basically it's saying x has to be greater than any number above 3. So we can use a number line to demonstrate what this means. We cannot use a number line really for the equation because x is equal to one number, but x is greater than 3 means x can be an infinite set of numbers, any number greater than 3. So here's a number line, and the left side of 0 are the negative numbers, the right side of 0 are the positive numbers. So here's 3. Okay, so basically you draw a circle. You don't shade the circle because x must not be equal to 3. And then you draw a line, an arrow, showing in what direction x can be found. Any value greater than 3 can be the value for x. Don't shade because x must not be equal to 3.